Dear students, we are going to study now the reflection of a wave. Here, as you can see, I have created a pulse, and this pulse gets reflected from this boundary or a rigid surface. And as you can see, now I have created one pulse, and it gets reflected here. When it reaches here, then it gets reflected here, as you are able to see. After reflection, what we are seeing that there is a 180-degree phase shift. The amplitude remains same, but it is when it is moving in positive x direction, after reflection it gets 180-degree phase shift, and the same here, after reflection it gets 180-degree phase shift. Dear students, now the first question arises in your mind: what is reflection? So before that, if I increase some damping, means there are some energy losses. Then what will happen? After each reflection, the amplitude decrease, and eventually the amplitude becomes zero, and there is no traveling wave. So let us come back. What is reflection? The when a pulse goes from one place or one medium, and when it strikes or it incidents on a boundary or an interface separating two media, then when it reflects back, when it bounces back in the same media, then it is called reflection. There can be a reflection of light, sound, and here we are studying about reflection of a pulse or reflection of a wave. Dear students, this is one pulse, second pulse, third pulse, fourth pulse, and this is a now we have created a wave. This wave is traveling, right? If, dear students, there is no any such boundary, there is no boundary condition, then what would happen? It will travel, it will not return back. So returning back and traveling forward pulse and returning backward pulse, they superimpose, they add with each other, and we get some superposition of wave. So here I am going to cover again the superposition. For that I am creating damping 0. Dear students, I am creating one pulse, the pulse return backs. Now what I am going to do, I will create another pulse when it will meet this pulse. For example, when I create another pulse and when it meets this pulse, then you will find that a positive pulse and negative pulse creates a 0. It is called destructive interference, and in constructive interference we will have a maximum amplitude. So dear students, let us see. This is pulse is moving, and I should decrease the speed of this pulse so that you can very clearly observe the addition of the waves. Yes, when it goes from here, I'm creating a second pulse. This second pulse, as you are able to see, when it meets the first one, then here at this place the amplitude increases. Here it becomes 0 because they were moving in opposite directions, and here as you will find that some amplitude decreases. On the other hand, if I create one pulse and this pulse meets a pulse which is in the opposite direction, then 0, and if it meets the in the same direction, then you will find that the amplitude increases. For example, I am creating a loose end. Loose end means open boundary, and when the pulse get reflected from this place, there is no phase change. If it is moving in this phase, the same phase it will return back. And in the same way, when a pulse strikes a open boundary, this is called a open boundary, it reflects back at the same angle, and I am creating a second pulse. What you will find that when these two pulses meets with each other, we get a maximum amplitude. Here we will get 0. Why? Because positive negative becomes 0, and here again you will find maximum amplitude because it is a constructive interference. So destructive, here destructive hoga, and here it is a destructive interference, and then you will find a constructive interference because two pulses meets with each other. So let me stop it. And what I have taught you, let me create a summary.